everyone. I'm posting an extra example for working through word problems. This is one that I will do in class as group work for face-to-face classes. So I have this function n of t, and it gives the number of sunspots t years after 1900. And a lot of this will come from just thinking through what the graph looks like. The solving part will come a little bit later in the problem. So first thing, we're supposed to find the maximum number of sunspots. How often will the number of sunspots reach its maximum? First time it reaches its max, minimum. Okay, so if I'm thinking about the graph of this thing, I know that my equilibrium is at 60, and that my amplitude is also 60. So the top of this thing is going to be at 120, and the bottom is going to be at 0. This thing being the cosine wave. So the maximum number of sunspots that we're going to hit is 120. And the minimum number of sunspots will be 0. I'm going to zoom in a little so that I'm not struggling so much to make this fit. Okay, we also want to know how often it will hit that maximum. So that to me sounds like a period question. If I know the period, I know how often it goes from max to max. So this number right here is going to be key for finding my period. If I want to find my period, it's going to be 2 pi divided by 2 pi over 11, which is the same as 2 pi multiplied by the reciprocal, 11 over 2 pi, which means the period is 11 years. So it will hit its maximum every 11 years. Okay, and then we're supposed to find the first time that it hits its max. So this actually might be kind of a tricky one. What do I see? I see shifted right by 100. So if I think about cosine, it usually, whoa, hold on, I don't know what's happening, craziness, hits its max at 0, 1. This one has a lot of transformations going on. So we have vertical stretch by 60, which means this will actually happen at 0, 60. And then we have shift compression. Let's see, what is that? 2 pi over 11. So stretch, actually, I think is what that is. Period is 11 instead of 2 pi. That won't change the 0. And then we need to shift up 60. So now the max is actually at 120, which is what we said before. And then we need to shift right 100. So it's going to move. Wow, this thing is being crazy. One of my maximums to 100, 120. But that's not necessarily the first time after 1900. That's in the year 2000. So I would guess that we have one before that, and I can use the period to work my way back to it. So there was one at 100, but there would also be one at 89 and at 78. Wow, crazy pen. And at, what were we at, 78, 67. Jeez. And at 56, and at 45, and at 34, and at 23. And if you recognize the pattern, you can skip all these steps. And at 12. And then at 1 is the last one that I hit. I want to stop before I get to 0 because the question was 1901. Find the first year after 1900, and if we hit 0, then that is 1900, and if we hit a negative number, that's before 1900. So we could keep going. We could go back 11 and we could get negative 10, but that's talking about 1890, and we're looking for the first year after 1900. So just use that period to help you jump from one max to the next. List all years between 1900 and 2000 in which the number of sunspots is at its minimum. Okay, well, I'm probably going to get lazy and not list all of them because I think I remember that this is a tediously long list. But what I know right now is that it hits its max in 1901 and then again in 1912. It should hit its minimum exactly in the middle of that. So it would be right in the middle of, let's see if I can count here. We need 5.5, half of 11. So 1906, right in the middle of 1906. And then again, you would just use that period to repeat. That should be the first one. The next one is 11 years later, so 1917. The next one is 11 years after that, 1928. The next one is 1939. And then I'm just going to ... So there's definitely more of them, but that's the idea there, is just can you figure out how often those things happen and when one of them happens and use that to get a whole list. Okay, next one, find the average rate of change from t equals 100 to t equals 110. Okay, so if we want the average rate of change, we're going to need n of 110 and n of 100, and actually I think we already know n of 100. I erased it at this point, but n of 100 should be a max. You can always plug it in your calculator and check, but since we know this thing is shifted by 100, we know it should hit its max of 120 in year 100. So then we just need to figure out where it's at in 110, so hold on for a minute while I do some off-screen calculator chugging. We'll see if I have this phone calculator in the right mode. I think I do. Okay, so I need 60 plus 60 times cosine of 2 pi over 11 multiplied by 10. Okay, do I have all of it? I think so. And I got roughly 110.48. So to do the average rate of change, I'm going to take the 110.48 minus 120 divided by 110 minus 100, which is 10. Do I want to do arithmetic in my head? Maybe I do. It doesn't look like it's too terrible. Okay. So I guess the first one was approximate, but this is going to be exact. 9.52 over 10, which is going to give me 0.952. Oh, and it's negative, sorry. Arithmetic in my head made me not careful with my signs. And then we're supposed to explain what that means. So if we think about this problem, I'm going to look back up at my little beginnings of a graph up here. This is t, which is years since 1900, and then n on the vertical axis, which is number of sunspots. So this should be change in n over change in t. So if we do it per 1 year, this would say between the year 2000 and the year 2010, the number of sunspots was decreasing by about almost 1 sunspot per year on average. So something along those lines. So again, the years part comes from the t equals 100, the t equals 10. So between the years 2000 and 2010, and then again this 0.952 is almost 1. So the number of sunspots is decreasing by about 1 per year on average. Okay, and then to the last one here, find the first 3 years after 1900 in which there are 90 sunspots. So this is telling me that n of t is equal to 90, and it's asking me to find some t's. So this is a solve problem. Okay, so let's see. If we look back up at our equation, we're setting 90 equal to 60 plus 60 cosine of 2 pi over 11 times t minus 100. And this is where things get a little messy. So we want to start solving, and basically our first goal is to isolate the trig function here, and then we can go to our unit circle and use some of our other tricks. So if I'm going to isolate the trig function, the cosine, I need to subtract 60 from both sides, so I'm going to get rid of this, which is going to leave me with 30 equals 60 cosine 2 pi over 11 times t minus 100. And now I'm going to divide to get rid of the other 60, which actually works out really nicely. Cosine of 2 pi over 11 times t minus 100. Okay, and as soon as you get that trig function isolated, you can think about your unit circle. Right now we're just going to ignore all the mess inside the function, the 2 pi over 11 and the t minus 100. And we're going to see if we can figure out what this all has to be in order to get 1/2 out of cosine, which is a nice thing to try to get out of cosine. So that's telling me that my x has to be 1/2, which means that my angle could be, for example, pi over 3, and then the symmetry on this one is negative pi over 3. So I'm going to say that's my picture for, I don't know, call this theta. Theta should be one of those two things. So we're going to say that now plus or minus, let me think about what order. No, that'll work. Plus or minus pi over 3 should equal all this stuff inside the cosine, because all the stuff inside the cosine is my angle. And then I can work with the plus or minus as I'm solving this, so I think I will. So I'm going to multiply both sides by 11 over 2 pi. You can do things in other orders, but that'll get rid of that nicely. 11 over 2 pi. So on this side, all gone. And on this side, the pi's cancel, and I get plus or minus 11, oh, I'm looking at pi's, 11 over 6. And then on the other side, oh, the pi is gone as well. I just have my t minus 100. So it looks like t is going to equal, if we add 100, 100 plus or minus 11. I can't write an 11 now. 11 over 6. Okay, so again, this gives us one of the years. In fact, two of them, because I have a plus or minus, but it doesn't give me necessarily the first three. So I'm going to say, what is 11/6? It's 1 and 5/6. So we have 100 plus, well here, let's just say it's this. 101 and 5/6. You will rarely see me write a mixed number, but for this one we're going to kind of ignore it in a minute, so that's okay. And then if we subtract 1 and 5/6, we get 98 and 1/6. Okay, and then again, this is years after, so 101 and 5/6, this is right at the end of 2001, and this one is right at the beginning of 1998. And the way it says in which years, so I'm not really worried about whether it's the beginning or the end, so I'm just going to keep this. And then again, I'm still not quite done, lots to think about in this one. That's great, that's 2 times when there will be 90 sunspots, but I was asked for the first 3 times after 1900, so now I have to go back to that thing I was doing where I say, okay, well, 2001, that's fine, but I need to work my way backwards. So the period is 11. If I subtract 11 from that, I'm going to get 1990. And if I keep doing it, I'm going to get 1979. And then I'm going to get 1968. And I'm going to get 1957. Hopefully I'm counting right. And then I'm going to get 1946. And 1935 and 1924. 1904, 1913, and 1902. Okay, so now it's starting to look more promising. So I would say for sure I'm going to want this 1902. Maybe I'll want the 1913. Let's follow this one back and see how it works out. Okay, so I need to subtract 11 years, so I'm going to get 1987, and then 1976, and 1965, and 1954. Oops, we got an extra comma. 54, and 1943, and 1932, and 1921, and 1910, and then if we subtract 11 again, it gets negative, so that's going to be the second one, and 1913 will be the third one. Okay, so this is a messy one, and there's a lot in this about using your period and understanding that when you solve these things, you get a solution, but it might not be the one you were looking for. So hopefully that helps a little bit. Again, let me know if you want to see other problems or if you have questions.